what we will do in Automata, it will deal with abstract computing devices. Turing studies as Turing machines, computers. Before there were any real computers. So we will look at simpler devices than Turing machines like finite state automata, pushdown automata, with respective types and their specifications such as grammar and regular expressions. That will be discussed in a later part of this course. NP hardness, normally known as non-deterministic polynomial time hardness, that is the most difficult part of computation we will face. So the efficient techniques will be learned in this subject. Now, what is computation? Simple concept is there is a CPU, there is some processor, and a memory is involved. Data will be transported to and fro from memory side towards CPU, and after processing, the result will be sent back to the memory. This is the basic concept. So there is some temporary memory that normally termed as RAM, and you have some input and you will get some output, and you have a program memory, and you need to compute, actually you need to compute x cube. Now first of all you will compute x cross x, it will be x here, then after that you will compute again, multiply the result with x again. So in this way you will get the result x cube. Let's suppose you have a value in input memory 2, and you will put this data for computation, and first step you will have, when x is 2, then it will be 2 plus 2, that will be 4, and then the result will be in the variable z. And now variable z contain 4 value, which will be again multiplied by 2. The result will be 8. That exactly our required result, x cube. Now automation actually involves the processor and the program memory. Input is coming and temporary memory is used to gather some data, and the program memory will tell you that what should be done, and then after you will get output as well as the result will be displayed on your monitor. So these are the different types of automata. Automata are distinguished by the temporary memory. Number 1 is finite automata. There is no temporary memory. Number 2 is pushdown automata. You will have the stack. And number 3 is Turing machine. You have random access memory. So the first part, in finite automata, you will not have temporary memory. You have only input memory and output memory, and there is finite automata. They are simple vending machines, small computing power, because there is a limited space for input and you will have limited space for output as well. Now next one is pushdown automata. You will have a stack. You know that you can perform push and pop operation here. So for example, compilers for programming language, so it has medium computing power. Either you will perform a push operation or you will perform a pop operation at a time. Third one is the Turing machine. You have RAM, so you can get data and you can send instruction for more data. So there is two-way communication, but here you will have either push operation or pop operation. So there's a basic difference between both of them. So you will have an input memory again and output memory for respective processing. So an algorithm suits this model. So you will have highest computing power in this mechanism. So this is the comparison between these types. If you are residing on finite automata, then you will have less power, less processing power. If you are on pushdown automata, you will have a medium power, and if you are on Turing machine, then you will have highest power to perform any task.